All right, let's go ahead and finish up chapter 5. We're on to 5.7. So we're looking at using triangle congruent. And so our essential question is going to be, what is Cpctc and how do I use it? Okay? All right, so here's the idea, right? This whole chapter we talked about that if we wanted to show that two triangles were congruent, we would take all 6 parts, right? All 3 angles on both triangles and all 3 sides. And we'll show that every single pair is congruent. So the 6 things you have to do, right? 3 angles, 3 sides. And we found 5 different tricks on how you can do that shorter, right? We have SAS, SSS, AAS, ASA, HL. I think that's all 5. And those 5 tricks allow us to get to congruent triangles easier, okay? And so the very obvious, but somewhat, like, with the stated still, conclusion of that is that if we have 2 triangles that are congruent, then certainly all of their parts are congruent. That's what this means. So if 2 triangles are congruent, then their corresponding parts are congruent. That's the theorem, okay? We're going to call that Cpctc. Corresponding parts of congruent triangles are congruent. Cpctc. Okay? So if you wanted to show two sides of a triangle, of 2 different triangles are congruent, you could show that the two triangles themselves are congruent, and since the triangles are congruent, then their corresponding parts are congruent. It's really obvious, right? Like if you concluded that triangle ABC is congruent to triangle DEF, then certainly, since those triangles are the same, then these 2 angles are the same, right? That would be your line of thought, all right? So let's go through some examples. Here is an example from your homework, okay? So it's kind of small, I'm sorry about that, but it says explain how to prove that statement A, the statement angle A is congruent to angle D is true, okay? So right here, we have 2 triangles. Now remember, we have this side and this side are the same, this side and this side are the same, this side is the same as itself by the reflexive property, right? And so now we have congruent triangles. So triangle ABC is congruent to triangle B, triangle D, and then it went from A to B, so it'd be DBC. Those 2 triangles are congruent by SSS. So what we have, DBC by SSS, because of Cpctc, because the corresponding parts of congruent triangles are congruent, angle A and D are the same. Okay? That's the whole logic. So show the 2 triangles are the same. Since the triangles are the same, their parts are the same. Okay? That's all there is to it. Alright, number 2. This is an actual proof. Given that triangle SUT is congruent to triangle WV, so SUT, WUV, prove that angle S is congruent to angle W. So, short and sweet, right? We said, hey, triangle SUT is congruent to triangle WUV. That's given to you. But now, do you even need this picture? No. The first ones are S and W. And if these triangles are congruent, then their corresponding parts are congruent. And certainly S corresponds to W by this congruent statement. So angle S is congruent to angle W. And all we're going to write is Cpctc. Okay, that's enough information for me. That'd be a super simple proof, right? Alright, next page. So we're going to do a few of these. Okay? Prove that U is the midpoint of TV given this is true. Okay, it's a little bit more tricky, right? Because we're not actually concluding something obvious. But you're starting with the given. Okay, the triangles are congruent. Now look at the picture here. If we want U to be the midpoint of TV, notice that by the definition of midpoint, if these 2 sides are the same, then U's in the middle, right? But we can say that. We can say that TU is congruent to UV by Cpctc, right? This side right here and this side right here are the same because the triangles are congruent, so all the corresponding parts are congruent. And by the definition of congruence, U is the midpoint. By the definition of midpoint. Since those 2 sides of it are congruent, then U has to be in the middle, okay? So really we're just jumping through hoops to say, hey, triangles were congruent. And so the hard part is usually getting this. You're not usually just given that, right? All right, another easy one, right? Given that triangle AEB, this one, is congruent to triangle CED. So let's go ahead and write it. You're given it this time. Prove that CD is congruent to AB. Well, we're done, right? So if you understand these statements, remember the first letter is the same as the first letter, second is the same as the second, third is the same as the third, and then you have the three segments, AE, CE, EB, ED, and CD and AB. All of those parts are congruent because those triangles are congruent. So we get to just conclude that these two parts are congruent by Cpctc. The triangles are already congruent, so all the corresponding parts are. Anything that falls into that statement is already done. So we know that these two parts are, which one do they want? CD? Yeah. These two parts are the same based on the triangles being congruent. Okay, it's the same triangle. Number 5. Okay, a little trickier here. So, given the triangles are congruent, let's go ahead and write it. So these triangles are the same, left and right one. Okay, we want to prove that CA cuts DB in half. Remember, this means cut in half. And if something is cut in half, that means that either side is the same, right? So now I have the wrong ones marked. Sorry, let's just cross those out. Like this, right? CA cuts DB in half. So all we need to do is show that DE is congruent to EB. That's what it would take here. So we can actually just conclude that DE is congruent to EB, and that just comes from the fact that Cpctc, the corresponding parts of congruent triangles are congruent. The triangles are already congruent, all their parts are the same. So these two are already marked, hence CA bisects DB by the definition of a segment bisector. So obviously the hard part of that one would be getting this part right here. But you know that if I say, hey, show me that this segment cuts DB in half, you would need to show that either side is the same. So this is the important step here. Okay? And we are on to our last example. Given the triangles are congruent, let's go ahead and do it again. Triangle STV is congruent to triangle UVT. It's given to you. Prove that ST and VU are parallel. So remember, when we have parallel lines like this, we're almost always going to have that chapter 3 stuff with corresponding angles, alternate interior angles, and so on. And remember, we had the converse of those. So it was, if the two lines are parallel, then the alternate interior angles are congruent, or the converse, if the alternate interior angles are congruent, then the lines are parallel. That's what we're going to use here. So what we're going to do is we're going to show that these two angles are the same. Those are alternate interior angles. Okay? So we'll go ahead and say this. Angle V is congruent to angle T. Now remember, we're proving the lines are parallel, so we can't use that. These are congruent because of Cpctc. The triangles are congruent, so all the parts are congruent, corresponding parts are, and so V and T are corresponding, so they're congruent. And now, ST is parallel to VU by the converse to alternate interior angle theorem. If the alternate interior angles are congruent, then the lines are parallel. Okay? So that's all there is on that one. Now, usually what's going to be is it's going to be a little bit more work to get to this point right here, and then you will find some conclusion based on that. So these are like a couple step conclusions based on that. Nothing too crazy, but that ends chapter 5. So this is all we're going to do before we go back to hybrid. Hopefully this made some sense. Good luck on the review. Good luck on the quiz. Have a good one.